Hello, this is a video about Pythagoras' theorem, what it is, how to use it, the history behind it, how to prove it, and how to problem solve using it. So yeah, let's get into it. So let's start with the history. This is Pythagoras. He lived in ancient Greece, smart guy. Yeah, contrary to what you'd think, Pythagoras wasn't the first to use the Pythagorean theorem. He wasn't the first to think of it, and he wasn't the first to understand it. Babylonians, Indians, and Chinese all did it hundreds of years before him. They all beat him to it. But the reason why we don't credit them with it is because while they used it, they couldn't prove it. In mathematics, proof is it's a big deal. You need to prove things before you can use it. So we credit Pythagoras with this theorem because he proved it. He then made a secretive brotherhood. And it's called the Pythagorean Brotherhood, creatively named. And they believed that reality was ruled by numbers. They were a bit of a cult, or a bit strange. They, it's a bit of a, I don't know if it's a myth, but apparently they chucked a guy overboard because they proved that root 2 was irrational. Crazy people. So how did he prove it? So he got this square, which is embedded inside of another square, in such a way that it creates 4 congruent triangles that are all arranged in this pattern. So what we're going to do is we're going to find the area of the bigger square, okay? And there's 2 ways to do that. We're going to find the whole area, but if you find the area of the big square, what you do is you add together a and b on the sides, and you square it. And then that simplifies to this, a squared plus 2ab plus b squared. And then what we're going to do is we're going to find the area of the little square, and we're going to add on the areas of the 4 triangles. Because then, if you add them together, that is clearly still the area of the whole square. And you get c squared, which is the square bit, the little square. And then you got 4 over 2 AB. So 4 lots of half base times height. 4 lots of the triangle. Okay? Simplify that a little bit. 4 over 2 is just 2. Cool. As these are the area, the same shape, these 2 expressions must be equal. So if you just put these equal to each other, you can see that 2ab appears on both sides. So if you just subtract that, you get left with a squared plus b squared equals c squared. Easy. And yeah, that's how Pythagoras proved it, and this is why we credit him with the discovery of the Pythagoras' theorem. So what does the theorem say exactly? We know that a squared plus b squared equals c squared, but what do these represent? So it encodes a relationship between the lengths of the 3 sides of specifically a right-angled triangle, which looks like this. This is how we geometrically represent it. So a squared is one of the smaller squares, and so is b squared. These areas add up to the big square, c squared. Okay. Things to know about it. It must only be used on right-angled triangles. C is the length of the hypotenuse. Okay. And the hypotenuse is the longest side. It is the side opposite the right angle. Yeah, that's how you identify the hypotenuse, which must be C. A and B, though, it doesn't matter which one they are. It's just the other sides. Okay, you can choose which one's A and B. It's your decision. So, let's go through an example of how to use it. So, example 1, finding the hypotenuse. So, we've been given 2 of the sides. We need to use the theorem, we need to be given 2 of the sides. So we're going to identify the sides first. So we know we're going to choose A to be 3.2. It could be B, it doesn't matter. A and B, it doesn't matter which way round you decide. But yeah. So then C must be X, because that's what we're looking for. C is the hypotenuse, that's what we're looking for. Okay. So we're going to use the theorem. A squared plus b squared equals c squared. Okay. Just plug your numbers in. 3.2 squared plus 1.7 squared. So we replace A with 3.2 and we replace B with 1.7. And then you can simplify the left side then. Probably going to use a calculator here, but yeah. And then once you've got that x squared, now this is a common mistake. People will often just leave it like that. But no, we're looking for x, not x squared. So you're going to square root both sides, and you get the x equal to the root of 13.13, 3.6235. If you look at the question, it tells you that you have to give the answer correct to 3 significant figures. So 3.62. Just a quick interlude on square roots, because, well, they're so integral to using the Pythagoras theorem. You're pretty much always going to use them, but there's a little bit of misconception that comes with them. Every number has 2 square roots. This is true. Okay. In case 1, this is when you multiply a positive number with another positive number. Okay. So positive x multiplied by positive x is equal to x squared. Okay. So therefore, positive x must be a square root. This is how we normally do it. This is how we normally think of a square root. Okay. But there's a second case. This is when you multiply a negative number by another negative number. And we know that must result in a positive. So this also equals positive x squared. So therefore, using this logic, negative x must also be a square root. Okay? So when we use Pythagoras' theorem, why is it we just completely ignored the negative square root? Well, it's just because negative distance in real world, unless you're talking about displacement, makes no sense. We're talking about magnitudes of distance. This makes no sense. Okay, back to Pythagoras' theorem. I'm going to use a second example here. We're going to find the other side. So now we're finding A or B, not just the hypotenuse. Okay. We're going to start the same. We're just going to identify our sides. So we're going to call A 8. B here must be x, because that's what we're looking for here. Remember, A and B could be either way around. But C must be 16, because it's the hypotenuse. Cool. Now we're going to rearrange. A squared plus B squared equals C squared. Yes, so we're not solving for C squared anymore. So this is the extra step in this example. We're not solving for C, the hypotenuse. We know C, we want B. So we've got to take away A squared from both sides to get B squared by itself. Cool. Then we're just going to substitute in again. So x squared, which is the same as B squared, is 16 squared minus 8 squared. Simplify, square root, remember ignoring the negative square root, 13.86, and that's already correct to 2 decimal places. Cool, done. Okay, so in example 1 and 2, they were your straightforward, just apply Pythagoras' theorem questions. You're going to get about 2-3 marks for them. They're going to be earlier on in your papers. This example, though, where you can't directly just apply Pythagoras' theorem straight away, this is going to be your 4 or 5 markers at the end of the paper. Okay, so this is the problem solving. This is where you've really got to focus to get marks. So, but we're going to, same steps. Step 1, identify what I need. And essentially we're just going to work backwards. Okay, we're going to start with what do we want and then how are we going to get it. Okay, so we've been asked to find the length of AC in the question. That's what it says. Calculate the length of AC. That line. Okay. So in order to do that, this forms a right angled triangle with AB. Oh, what have I done? Yep, AB and BC. AB, BC and AC. That is a right angled triangle. We only know AB so far. So in order to find AC, we need BC. Okay. But that is going to be the same as if you move up as this line here, which I'm going to call this DE. I'm going to call that E on the side, okay? That length must be exactly the same, okay? So, that forms a new right angled triangle with AE, ED, and AD, okay? But in order to find DE, we need the length AE now. Okay, but we can find this length. So this is where we're going to start now. How are we going to find that length? Well, hopefully you can see that AE is going to equal AB take away DC over there, because these lengths, this length must be equal to DC, okay? So if you take that away from AB, you'll get AE, okay? So 9 minus 3 is 6, cool. So now we can use Pythagoras' theorem in order to find DE. And then, you know, we're going to do our normal. A is equal to 6, B is equal to X, and C is equal to 10. Be careful, we are definitely using the rearranged version here, because we're not solving for a hypotenuse, okay? So rearrange, plug in your numbers, and carry it out, just like normal, okay? Just how we've done before, okay? So now we know DE. What we need now is, well, we know that's the same as BC, so we now know that that's 8. So now we have enough information to calculate AC. So A is going to be equal to 9, B is equal to 8, C is going to be equal to X, okay? Exactly the same as before, just carry out that calculation, and it says to 3 sig figs. There, done, okay? That method, that question was kind of long, but the method is the same for every kind of problem-solving question. Start with what do I need, work your way back. How are you going to get that? And then eventually you'll find a point where I have enough information to figure that out, and then keep going forward to get my answer. Hopefully you've realised by now, Pythagoras' theorem doesn't involve nice numbers. Okay, they're kind of tricky, and you'll always kind of have to round it off. Well, I say always, most of the time. Reason why is because it involves a lot of square roots, and, you know, most square roots, if they're not perfect squares, they're going to be irrational numbers. They're going to be surds. Okay? But in a few select cases, you're going to get some integer solutions, some nice number solutions. Okay? Some whole number solutions. For example, you can get 3, 4, 5 triangles. So the shorter sides will be 3 and 4, and then the hypotenuse will be 5. 6, 8, 10. 5, 12, 13. Yeah, so these are the main ones you're going to be looking out for. But they're good to look out for because they save you a lot of time. Here's an example of it. You know, you could go through the normal long route and, you know, it'd take you a while, but you'd get to your answer. Or you could just realise it's a 3, 4, 5 triangle. 5. Done. A lot of kids often ask in maths class, you know, so why is this useful to know? Well, the answer is it's used in construction to make sure walls are upright. You know, it's difficult to measure 90-degree angles sometimes, so you can use Pythagoras' theorem to make sure it is. If Pythagoras' theorem is true in a situation, then it must be a right-angled triangle. Yeah? Okay. GPS is used to find the shortest distance between 2 points. Physics used to find displacement from an origin, to calculate a distance between 2 objects. You know, and real life, you use it to find the length of a TV screen. So any situation where you have things like that, you can use it to find distances. And you're always going to have situations like that because the XY axis. If you have an X and then a Y, you know, you can calculate distance from the centre by using Pythagoras' theorem because X and Y axes are at right angles to each other. But historically, the theorem is significant because it's the first time anyone ever realised, really, that there's a connection between numbers and reality. And it's the first time anyone ever really noticed that. And that's why Pythagoras was such a smart guy and his brotherhood was... They were ahead of their time. You know, now it seems kind of obvious. But, you know, before then, we just thought numbers was for, you know, counting coconuts. Yeah, so I just wanted to say thanks for watching. It'd be great if you could like and subscribe. It's a new channel. I'm trying to grow it. No, I shall be from here going forward. But yeah, thank you for watching. It'd be great if you could show some support.